Hey everybody, for today's video, I'll be going over the grid questions for section 5.1. Starting with question 34. The integration of 36 squared over pi cubed minus 15 sine 3x is equal to ix plus c. They're asking us for what is I pi. First and foremost, we will integrate the equation. So the integration of x squared right here is x3 over 3, as I'm sure you guys know, and you multiply it by its coefficient, which is 36 over pi cubed. So you'll have 36 times x cubed over 3 pi cubed. Then you have 15 sine 3x. The integration of sine u is equal to negative cosine u over u prime. So in this case, sine 3x will be equal to negative cosine 3x over 3. Since you already have a negative here, it cancels out and becomes positive. So when you simplify them, for example, 36 and 3, you'll get a 12, 15 and 3, you'll get a 5. So the equation right here is 12x cubed over pi cubed plus 5 cosine 3x. Next, you will just have to substitute pi into the equation in order to find it, which if you calculate it, you will get 7. Moving on to question 35. Again, it's all simple integrations. So 192x to the power 2. This would be x3 over 3 times 192. These cancel out, you get 64. If you have a constant, you just multiply it by x. Now, for secant square cube pi x is where it gets a little confusing. You guys will have to remember all the derivative equations. So the equation of tan derivative is equal to secant squared x. And since integration is just antiderivative, the integration of secant squared will equal to tan x. Therefore, secant squared x integration will simply give you tan pi x. The inside will always be the same. So when you simplify, you get 64x cubed plus 8x plus 3 tan pi x plus c. Since ix is the equation without c, you'll substitute 1 over 4 into this equation here, which will give you a 6. Moving on to question 36. We have 12 cosine x minus 6 sine x. If you recall the previous formulas I wrote down, the integration of cosine is sine x over derivative, which is 1 in this case. And for sine, it is negative cosine x divided by the derivative of the inside, which is 1 as well. So you will get 12 sine x plus 6 sine x plus c. C you can remove it since you're only looking at theta. So if you substitute theta into the equation, you have 12 sine theta plus 6 sine theta. They already gave you that cosine theta is equal to 4 over 5 and sine theta equals to 3 over 5. So you simply substitute and calculate. You will get 12. Moving on to question 37. What I prefer to do is to separate the equation. Rather than having it as a complete one, you'll have 2x over x4 minus 7x squared over x power 4. You can simplify this to get 2 over x cubed minus 7 over squared. And then integrate as so. The integration of x to the power of negative 3 is x to the power of negative 2 over negative 2. The 2 in this case would cancel out, so you'll be left with negative 1 over x squared for the first part, as you can see here. And for 7 over x squared, it would be x to the power of negative 2 is equal to x to the power of negative 1 over negative 1. Therefore, the equation is negative 7 over x. The minus cancel out, so you have a positive 7 over x. So your final equation will be negative 1 over x squared plus 7x. This is your ix. Then you simply substitute, you will get 12. Moving on to question 38. Again, I will hope you guys will recall all the derivative formulas that you learned previously, because the derivative of tan x is secant squared x. The integration of secant squared x is tan x, because integration is simply antiderivative. What we can do here for question 38 is split this into two separate integration equations. So secant x times 8 radical 2 tan x minus secant x times 7 secant x. Make sure you have a minus separating it, because in the actual equation it is negative here. Then we'll look at one equation at a time. So let's look at 8 radical 2 tan x secant x. If you can see here, the derivative of secant x is tan x secant x. Therefore, the integration of tan x secant x will simply be secant x. And 8 radical 2 is a constant, therefore it will transfer. Now moving on to secant squared x, I've already mentioned its integration is tan x. So this here will be your final formula, and you would just have to substitute pi over 4 into it, and you would get 9. Going over to question 39. This is where we start using the substitution formulas, or just the substitution method. So you have the integration of x squared times radical x cubed plus 9. You will have to take x cubed plus 9 as u, and then find its derivative, which in this case is 3x squared dx. If you isolate the dx, you'll have du 3x squared, and then just substitute these into the formula. So instead of x cubed plus 9, you would write u under the radical and substitute dx by du over 3x squared. The x squared right here will cancel out with the x squared there, and you'll be left with integration of radical u over 3 du. Take the 1 over 3 out of the integration, and then integrate as normal. You'll be left with 2 over 9 radical u cubed. What I did here is I did u3, because I3 is for when you have x. However, in this case we have u. It's the same as when you have boundaries and you have to change the boundaries. So I did u3, substituted 3 into x cubed plus 9, you get 36, and then you substitute 36 into your integration rather than simply 3. Do not forget to do this. Another method you could use is, instead of substituting, you transfer the x cubed plus 9 into the actual equation. So radical x3 plus 9 to the power of 3, and then substitute 3 directly into this, whichever way is easier for you. And if you calculate it, you'll get 48. Moving on to question 40. Again, we will be using the substitution method. So in this case, you'll take tan x as your u, as you can see. Find its derivative, which is secant squared x. Isolate the dx, you would get du secant squared x. Substitute into the formula, so tan x will become u squared right here, as you can see, and dx will become du secant squared x. The secant squared will cancel out, so we'll be left with 21 u squared plus du. Then if you were to integrate it, you'll be left with 7 u cubed plus c. 7u cubed is the formula for iu. And over here, this is for ix. So again, as I mentioned earlier, you could directly substitute tan x into the equation to get 7 tan x cubed and then substitute pi over 4 into it. Or you could find u pi over 4, which is 1, and substitute that directly into this equation, which will be 7. Again, whichever one will be easier for you, you will get the same answer either way. Now on to 41. 41, I personally do not use the substitution method. You do not have to, since you don't have to cancel out any other x's or any sorts. So take 2 out of the integration and you'll be left with x plus 2 5 to the power of negative 1 over 3. Integrate as normal, you will be left with 3 times radical to the power of 3 with x plus 25 squared as your ix. Then substitute 100 into your equation, you'll get 75. Moving on to the last question for section 5.1. Integration of 320 cosine x sine cubed x. And they're looking for I pi over 6. So you can take sine cubed x, you'll just take sine x as your u. Du would be equal to cosine x. Do not mix up the negative sign for when you integrate sine and when you derive sine. When you derive sine, cosine will be positive. When you integrate sine, cosine will be negative. Please do not confuse these two when you're solving. And continuing on, isolate the dx, you'll get du over cosine x. Substitute these into the formula. You'll be left with cosine x u cubed times du over cosine x. Cancel the cosine x. And 320 integration of u cubed du. Integrate as normal, you will be left with 80 times u to the power of 4 plus c. I repeat once again, you could switch in u into this equation, so you'll have sine x to the power of 4, and then substitute pi over 6 into it directly, or you could find out u on its own, which would be 1 over 2, and substitute 1 over 2 directly into u. You'll get 5 in both cases. Just pick whatever is easier for you to solve and what you understand better. That will be it for this video. Thank you guys for watching and I hope you learned something. Have a nice day.